Okay, folks, 5 o'clock somewhere, 11 o'clock right here, so please come in, have a seat. We're going to get started the moment you've all been waiting for, session 20. We have 5 really great talks in this session. I'll be moderating. My name is Runde. I work for the Nature Conservancy. Appreciate you all being here this late morning, last session before lunch. And with that, I'm going to hand it over to our first speaker, Ming Sun from right here in Stony Brook.
Okay, thank you. Okay, so my name is Ming Sun. I'm a research scientist at Stony Brook here. So in this talk, I will be talking about our project on characterizing the offshore wind farm impacts on NOAA fisheries survey data quality for Cape Mid-Atlantic fisheries. So the offshore wind development in the Northeast U.S. has resulted in many conflicts in spatial marine use. One of the effects is the preclusion effect of fisheries. But the offshore wind area can also preclude survey vessels from operating in certain area which they use to survey. So a recent publication on ICES this year interviewed fishery scientists from the Northeast US and Europe. In this interview, all the interviewees believe the offshore wind area interaction with fisheries independent survey are reflected in 3 aspects, including preclusion, statistical design, and changes in habitat. So although all the interviewees believe that these issues are important things to address to different importance degrees, but many of them are not clear what should be done and what can we do about the current status. So on the right side, it's a table summarized by the NOAA Fisheries and BOEM Federal Survey Mitigation Strategy. So this table outlined 13 federal surveys that are impacted by the offshore wind development in this area. And these surveys included 2 most comprehensive bottom trawl surveys for fall and autumn, and other surveys targeting certain commercial and endangered species. So basically, to develop mitigating strategies for all these surveys remain a large challenge and a lot of work, of course. So with this background, we started our project last year, funded by NYSERDA, to characterize the offshore wind impacts on NOAA fisheries survey data. So in this project, we aim to address 3 major challenges. First, we try to understand the offshore wind impacts on the survey abundance data. Then we try to understand how these changes can result in the performance of different stock assessment. And then we try to propose and evaluate potential mitigating solutions for stock assessment. So long story short, we try to work with survey data that are affected by the offshore wind area and to determine whether there are certain bias in abundance in space and time, and finally to figure out whether they could have an effect on stock assessment and abundance modeling. So in this project, we try to work with 4 species of different life histories and different stock assessment settings. And we also collaborate with NOAA Fisheries, ROSA, Management Councils, and DEC to disseminate our results to support their development of mitigating strategies. Okay, so for our project, we actually started by first doing some spatial analysis to understand the actual survey data, actual group of survey data that are impacted. So it's pretty simple. So we started by overlaying the bottom trawl survey historical totals with the offshore wind area in order to identify the totals that overlapped with the offshore wind area. So we did also some preliminary results analysis on this overlapped survey totals. So on the bottom left, we look at the survey effort loss for the bottom trawl survey measured with the totals overlapped. So on average, we're looking at roughly 10% of survey effort loss over time. And we then look at the survey sample loss for certain species on the right side here. We can see the sample loss proportion varied wildly by year, which means this can have an effect on how we interpret the stock abundance trend over time, and that trend can differ by species. So we then ask ourselves, what are the consequences of losing this group of data? The most direct consequence is that we were used to work with the full data set in the Northeast historically, but now in the worst case scenario, we have to exclude all the survey totals that are overlapped with offshore wind area, which give us spatially truncated survey totals. We call them outside data set here. You can see it has some significant gaps in space and also definitely much smaller sample size. So to work with this data set, There are several considerations to take. First, temporally, can we still use this outside data set to generate stock abundance time series that is comparable to the original data set? Secondly, can we simply use the outside data set to make prediction on stock abundance inside offshore wind farm area? To address these considerations, we perform some spatial temporal abundance modeling using the outside data set and evaluate their performance in terms of their prediction, precision, and accuracy. And in this talk, I'm going to use summer flounder as an example to show you some of the results and draw some implications on modeling and stock assessment. As for our modeling framework, we started by calculating the design-based spatial temporal indices, which follows a classic stratified mean calculation for most of the species that are used in stock assessment. And we also develop extra model-based solutions. So here we develop a suite of different model settings. We considered 2 statistical models based on generalized additive models. We also considered 2 machine learning methods that are supposed to be very good at making predictions compared to other models. And we finally considered VAST, which is a model that considers spatial temporal autocorrelation and random effects. And in terms of the variables, we try to incorporate both spatial, temporal, and environmental covariates to make sure we can kind of duplicate the models inside and outside the offshore wind areas. And these models were applied to both the full data set and the outside data set and compare their prediction performance in terms of trend, accuracy, and precision analysis. Okay, I'm going to jump directly to some of our results, skipping all the technical details here. So first, temporally, we calculate all the time series using the design-based and model-based approaches. So just by eyeballing look at this trend, we can roughly tell design-based abundance calculated with the outside data set is pretty comparable to the original data set, which is in red on the left here. And some of the model-based methods generate kind of reasonable results, but occasionally it has unreasonable fitting results because models can be sensitive to data, which we'll see in a few pages. And then we look at these results quantitatively. So first, by calculating the correlation between our estimate and the original data set time series. So again, we can tell that design-based indices calculated with the outside data set are very comparable to the original data set, which means it has a more than 0.9 correlation. But for other models, they perform relatively worse and around 0.75 correlation, and occasionally very terrible. So I want to highlight the VAST model here, which has been performing really well in many cases, but here we have one season that fit terribly. So just want to mention that we fit models used for different seasons and also annually, just to cross-compare their performance. But other than this terrible fitting for the season of May, VAST model actually performed the best compared to other models in terms of correlation. So we then look at the precision breakdown measured with a relative change in CV. There's a lot of figures here, and no need to read them all, but the simple takeaway is that the design-based outperform all the model-based approaches with very low relative change in CV. So very good precision. And occasionally we get a good estimate from VAST, but other models are pretty bad in terms of precision. And for accuracy, we basically get the same thing. So nothing comparable, even close to the design-based approaches. And we've seen a large performance disparity between seasons and models as well. So this is for temporal results. And we then look at the spatial prediction performance. So the first results we're showing here is basically comparing the changes in accuracy and precision by when we shift from using the full data set to the outside data set. So here we are showing relative changes in performance. So for accuracy, we show the results by regions, which include inside offshore wind area, outside offshore wind area, and the entire Mid-Atlantic region. So we are mostly concerned with the inside offshore wind area that we found that most models, basically all models, result in the loss in accuracy when we shift from full data set to outside data set, which means we cannot simply get as good as accuracy when we use the data set that is impacted by the offshore wind area. But if we look at for the other areas, when we simply use outside data set, we can probably get a pretty good accuracy for the abundance modeling other than offshore wind area, and sometimes for the entire area as well. But if we compare the results to the precision performance, we see something exactly opposite. So for the inside offshore wind area, 4 out of 5 models generate a better precision prediction compared to the accuracy. So this could imply a certain trade-off between losing precision or accuracy when you use model-based approaches. So particularly, some models that have the largest loss in accuracy can result in way better gain in precision. So it's either pursuing accuracy or pursuing precision, and we will discuss this later. So, but note that this page only shows the relative performance of the models. But if we look at the absolute performance, we see something totally different. So here we found that we use Taylor diagram, so it's kind of complicated, but the simple idea is the closer this colored dot to the observed purple dot here, the better prediction you have. So we found that the random forest model performed the best among all the models. But if you remember all the results from last page, actually random forest had the largest loss in accuracy compared to the other models. And the GAMS models are exactly the opposite. So here we want to highlight that some models can be highly sensitive to data, but this does not mean that they are terrible models. So relative performance and absolute performance are two different things, really depend on what you are trying to achieve. Okay, to summarize our project findings, so by far we can confirm that the exclusion effect on NOAA fisheries dataset can have an effect on how we model spatial and temporal abundance. And our modeling approaches can offer a solution to predict fish distribution with even the outside data set for the offshore wind area. But we also need to incorporate other variables, particularly environmental variables. Also, we believe this framework can be applied to other surveys and fisheries that facing the same issues. And what does this mean for stock assessment and abundance? First of all, we believe, at least for summer flounder, the design-based indices actually estimated using the outside dataset can actually be used as viable inputs to stock assessment because it's highly comparable to the original dataset. And we can even try some weighting optimization to adjust their weighting in the entire survey data analysis so we can make sure the stock assessment generate comparable results. And secondly, although some of our model-based indices did not perform close to the design-based counterparts, they can still provide valuable insights, probably even generate better stock assessment fitting results, but that's remains to be tested. Third, coming back to the precision and the accuracy issue. So by far, we know that with the offshore wind preclusion effect, it's pretty hard to achieve the perfect accuracy and precision at the same time. But some of the models can give you potential help in either pursuing a better precision or better accuracy. Now, I think this model selection finally comes down to what is your modeling objective and what are the characteristics of the species and data set you're working with. So basically, there are options, but really depends on what you need. Okay, so next step in our project is to conduct stock assessment and mitigating solution evaluation using these results, and also we believe these approaches can be helpful for future survey design, habitat suitability modeling, and other ecosystem modeling in the era of offshore wind development. So with this, I want to thank my co-authors and our founders for supporting this study. Also want to thank our collaborators for their input to this project. And I would like to take any questions from here. Thank you very much.
Okay, thank you, Ming. And we're going to get our second presenter up here, but please remember to continue to check the CVent app. The live Q&A is happening, so as questions come to you, please put them in the app. Our second speaker is Catherine Foley.
Hello, everyone. My name is Catherine Foley. I am a fish biologist at the Northeast Fisheries Science Center, NOAA Fisheries. And today I'm here to talk to you about our bottom trawl survey. This last fall, we celebrated 60 years of the bottom trawl survey. So I wanted to take a minute to talk about our time series, why we celebrate it, why we think it's so important, and some of the challenges that we're facing in terms of dealing with offshore wind, some of the mitigation that we're doing to try and combat those problems, the statistical design, and some of the other challenges that we're facing. But before I jump into that, I want to take a minute to say thank you, because I know for a fact that there are several of the people that are sitting in this room that have been on our bottom trawl survey and helped us collect data. And for a time series this long, it would not be possible for us to have done that without all of you helping us to go out there and collect data. So thank you to everybody who has helped us actually collect that data and contributed to that time series. So the bottom trawl survey, again, we celebrated 60 years in our fall bottom trawl survey as of the fall 2024 survey. It began in 1964. Our primary vessel for that beginning chunk was on the Albatross. Our spring bottom trawl survey started a little bit after that. In about 2010, we switched vessels and we moved our primary vessel over to the Henry Bigelow, which is another one of the NOAA white boats. For a period, we were also running a winter bottom trawl survey, which was more focused on flatfish. But during that time, you might have seen there were a few other vessels that were contributing to this effort. So there were a couple different vessels that were operating, but our primary vessels were primarily either that Albatross or that Henry Bigelow. But for this entire duration of time, we had surveys going out and producing data. And this data is used very widely. You hear us talking a lot about how these data are contributing to stock assessments. Right now, they're contributing to 54 different NEFSC-led stock assessments. Sometimes they're just producing small amounts of data that are contributing to those stock assessments. Sometimes they're almost entirely the sole data source that are going into these stock assessments. But that's not the only thing that they're used for. We are producing large amounts of data. It's not only abundance data, it's not only age data. We're also producing special sample requests for academic institutions. We are also producing stomach data. All of this is going into large amounts of papers. We are producing lots of data that is going lots of different places. So we really just want to highlight that the data that we're producing is widely used, and we are contributing to a lot of science that we think is really important to continue. So the design of our survey is a random stratified design that runs from Nova Scotia down to Cape Hatteras. And again, it's running on one of the NOAA white ships, the Henry Bigelow. It runs from shore out to the continental shelf. And when you overlay wind development areas and potential wind development areas on top of that, you can see it punches quite a few holes in the areas that we are attempting to survey, which when I look at that from my lens of statistical design and survey design, I gasp a little bit and say, oh my goodness, how am I going to think about designing a survey that deals with giant holes in the middle of what I'm trying to assess? But in addition to that, we're also dealing with other challenges. So when we think about the species that this survey was originally designed to study, so things like cod, and we think about what cod is experiencing in the environment, changes in abundance and distribution, how it's moving in the face of climate change, we start to think about how should we be surveying? We can also think about operational constraints that we're facing right now. So things like reduced sea days. We are facing changing weather patterns. We are looking at mechanical issues, things like federal budgets changing, staffing issues, rising fuel costs. We're also looking at competing ocean uses. So in addition to offshore wind development, we're also looking at increased fishing, fixed fishing gear, so just the places to be able to go do a tow. So we're looking at a lot of challenges when we're out there just trying to fish. And then we're also using a 60-year time series. So our survey design was designed in the 60s. And we are trying to use that as much as possible just to maintain consistency. But when we actually look at the survey design that we are using, sometimes we look at it and we say, oh, there's parts of this that we probably wouldn't replicate if we were designing this now. So just a reminder, this is a stratified random sampling design that again runs from Cape Hatteras to Nova Scotia. We're running from around a 9-meter depth to around 366 meters out to the continental shelf. Generally, we're stratified by depth and latitude, and our station allocation is generally proportional to strata area. But if you look at this map of our strata, you'll notice that we have some strata that are very, very narrow, particularly inshore and offshore. So those strata, in order for us to get measures of variation, need to have a minimum of 3 stations in them. So that forces us to have station allocation at 3 stations, even in some of these strata that are very, very small. So when we start to think about station density per unit area, It's not exactly uniform across the entire survey footprint. So if we were starting to think about how we would design a survey today, this might not look like what we would be doing if we were to redesign the entire survey. It also causes a bit of a lack of flexibility when we're trying to respond to some of these issues like offshore wind development or fixed gear preventing us from being able to tow as we would want to. So for example, when we think about the number of stations that we have the ability to tow in a given season, generally that's around 377 stations per season that we are able to complete across 82 different strata. So generally that means in an ideal world, we would be able to complete about 5 stations per strata. However, we need to complete 3 stations per strata in order to get an estimate of variance. In some of those narrow strata, great, but we have some massive strata. So when we're trying to place those stations across that entire area, it really limits our ability to be able to adapt as we need to across this entire range, and it forces us to place 51% of our effort in actually 23% of the area that we're talking about. So when we're thinking about how do we deal with this, first of all, we could just say, okay, well, let's scrap it. Let's just say that we're going to allocate stations proportionally to area. Never mind this 3 stations per strata rule. We're going to say that's not great. We want to get an estimate of variance, so we're just going to scrap that. Not a realistic option. We could also be reducing the number of strata, so just collapse the existing strata into fewer strata. So we're looking at that actively right now. But we want to do this in a way that's going to minimize the impact onto existing stock assessments. So we're trying to do this in a way that's going to keep in mind stock boundaries that we have right now. So this is something that we are actively in conversation with our population dynamics branch to try and figure out a way to collapse strata that would allow us to sample more effectively while minimizing impacts onto future stock assessments. What you're seeing here in this GIF is one potential realization of what that could look like. So that's a possibility. The next possibility that we are actively evaluating right now is thinking about using a spatially balanced sampling design. In this case, we're talking about using something called GRTS. So spatially balanced sampling is a form of random sampling. It's kind of a happy medium between random sampling and a systematic sampling design. GRTS in particular is a method that is random sampling, so it wouldn't be changing our design at all. It would still be a random stratified design. However, it would allow us to assign inclusion probabilities to every single pixel in our survey footprint so that when we're thinking about wind and places that we might not be able to survey in future, we could assign those pixels a 0 probability of being sampled, and it would not impact our survey design in future. So it would simply afford us greater flexibility, and a flexibility that we could account for in our survey design. So that's another option that is entirely possible, that we are actively evaluating and that we're planning to get reviewed, I believe, next summer. So now we start to think about, okay, these are things that are going on outside of the concept of wind development. They're just giving us the option to become more flexible, but they were already existing problems that we're dealing with. What about wind? So, in May of this year, we developed a survey mitigation plan for all of the surveys that the Northeast Fisheries Science Center currently has. I think there's 19 of them. And we had review panels on May 22nd through 24th. There was one for all of the fisheries plans, and the following week there was one for all of the protected species plans. Currently, all of those draft plans are available online, so if you have any interest, you can go and read all of them. We are currently working on finalizing them, and they will be available for public comment, I believe, in the fall. But to give you a high level of what's in the bottom trawl plan, generally, we're talking about increasing sampling around the perimeter of wind areas. So to give you just a general idea of what this might look like, surrounding a wind area, We would increase the probability of sampling using this method of GRTS. And we've found from our initial testing that in general, because of spatial autocorrelation, that sampling of all of the species that we've tested so far at small spatial scales, so if a wind area is small, then if we sample the perimeter of that station, we should get a general good assessment of what the biomass of that species is inside that wind area from what our samples are around the perimeter. However, this doesn't hold up as that wind area gets larger. So we're assuming at small areas of wind, this should hold up. But we're not relying on this alone. We're also talking about supplemental sampling. So we know that the large NOAA vessels are not going to be able to enter wind areas. They're not going to be able to tow in wind areas. So we're assuming that we will need another vessel to go into those wind areas and tow. But to make those tows from another vessel speak to our existing bottom trawl survey, we're going to need to have spatial and temporal overlap between them. So we're going to make sure that we have kind of a band of spatial and temporal overlap between them. That brings us to floating wind, which is a whole nother beast, which is where we're viewing this as to be determined. We need a lot more information to figure out what we're doing, but we're viewing this and we're actively working towards kind of a patchwork approach. We need to work with other survey modalities. We need to work with other survey groups, and we need to collaborate with a lot of people to figure out how do we fill in these gaps that floating wind is going to cause. So thank you very much, and I'll take questions later.
Okay, thanks, Catherine. Okay, our next speaker is Jason Kinnell. Keep checking the app, keep putting questions in. Is that up? Yeah.
Apparently, I'm starting with the end in mind, because I think this is, I don't think that's the beginning. Oh, right at the beginning. Well, good morning. My name is Jason Kinnell, and I am very excited to have the opportunity to talk to you this morning about some work that colleagues of mine have been conducting on evaluating the recreational and commercial fishing impacts for Attentive Energy One to inform the development of the commercial and recreational fishing section of Attentive Energy One's construction and operation plan. Yesterday, my colleague Matt Bingham talked about the approach that we're using for commercial fishing, and today I want to talk about the approach that we're using for recreational fishing. And our approach is consistent with guidance documents on how to develop a recreational and commercial fishery evaluation, and I would say most notably the importance of first developing a baseline characterization of the recreational fishery and then evaluating the changes under with project conditions to that fishery in order to have the most thoughtful evaluation possible. And before I get into kind of the details of the modeling, I want to just touch for a second on what we mean by thoughtful analysis from an economic perspective. Over the course of our careers, Matt and I have found that when we talk to people about economic analysis, typically what we'll get is the question of, okay, well, what's the number? What's your final estimate? What is the monetized value of the impact that you're evaluating? And that is the final culmination of the results and the research that we've undertaken. But what really is important is understanding the behaviors that underlie the potential population that is going to be affected by the particular research outcome that we're interested in. So in that way, our modeling approach is consistent with what is happening in space and time under current conditions, and how changes in those conditions are likely to affect the people most likely related to those conditions. And one of the things that we're super excited about relative to this research is that we found that Attentive Energy is very much interested and their thought is consistent with our approach and incorporating kind of that level of understanding into the development of the commercial and recreational fishing section of their construction and operation plan. So kind of with that backdrop in mind, and I've got to put my glasses on now that I can read here. I want to talk about the modeling approach that we're using for the recreational fishing evaluation. And the first thing, as I mentioned, is developing this baseline characterization. So the first thing that we had to do is say, okay, what is the level of recreational fishing activity that's happening in the relevant area where the lease area is off the coast of New Jersey? And what we see is when we go to NOAA's data on the level of fishing activity that's happening off the coast, the level of recreational fishing activity that's happening off the coast of New Jersey, what we see is there are roughly 2.2 million trips, recreational fishing trips, that are happening off the coast of New Jersey. The vast majority of them are by private recreational boating trips, but then there are party boating trips and charter boating trips. And so we needed to understand, well, what's the nature of those types of fishing trips and how are we going to model them? Well, because private boat trips account for nearly 95% of all trips, we said, well, let's start there. And what we did is we developed what we refer to in economics as a recreation angling demand simulation model. And we did that using a benefits transfer approach where we take an existing study in the literature, in the economic literature, that characterizes the types of behaviors that we're interested in, here specifically recreational anglers and their private boating trips. We take that preference function that evaluates how do recreational anglers make decisions on how much to go fishing, where to go fishing, based on the characteristics, and we take that information and apply it to those 2 million trips that we're aware of that are coming off the coast of New Jersey now. When we looked at charter boat trips, what we see is the underlying behaviors of charter boat trips are very similar to the private boat trips. And so what we've done in the analysis is scaled the results from the private boat trips to those charter boat trips. But when we look at party boat trips, those behaviors are both very different from the private boat trips and the charter boat trips, and there isn't a study in the economic literature that really looks at the behaviors of party boat vessels and the individuals that take those trips. So right now, within our analysis, we're handling the party boat trips qualitatively. On this slide, what I want to do is just give you a very high-level overview of the components of this recreational angling demand simulation model. On the left-hand side is the paper that we're using from the North American Journal of Fisheries Management. This is an analysis that Matt and others and I at Veritas Economics developed on recreational fishing decisions in New Jersey. And what we've done is we've taken that preference function and we've put it in the context of this nesting tree that's on the right-hand section of the slide, and it has 3 individual levels to it. It has a participation level, which basically evaluates whether or not people make decisions to go recreational fishing on an individual day or not. Then when they do, it has a target level specification that says, okay, what type of site do they go to? Do they go to a reef site or do they go to a sandy bottom site? And then within those individual sites, which ones do they choose? And the coefficients from the model that we're using are the coefficients on travel cost, which effectively in these types of models represents the implicit price that someone has to incur to take a recreational fishing trip, all things being equal. You'd rather go to a site that's closer to you than farther away. And then quality variables of the different sites. And here those quality variables are variables on catch and catch rate across 3 different species types. So saltwater small game fish, flatfish, and then other saltwater game fish. Here, what I want to do is give you a kind of visual depiction of both kind of the structure and the data that underlies the model. On the left-hand side is the baseline specification. Again, we have 2 million trips, 2 million recreational boating trips that we know take place off the coast of New Jersey, but we don't know where they go. So what we do know is that they're going to leave from different inlets in New Jersey. So we've identified the location of all the inlets in New Jersey. And we have data on the location of reef sites and various open ocean access sites, sandy bottom sites. And we also have catch rate data that's been collected on those different sites. So what we do is we evaluate the location of each one of those sites, use that preference function to simulate how those trips will be distributed through space and time from those inlet locations to each one of those sites. And then, under the with project conditions on the right-hand side, what we do is we go into the data and we change the catch rates in the lease area to be catch rates like the reef sites as opposed to the sandy bottom open ocean sites, rerun the model to make it a prediction of how many more trips are likely to occur overall and how many of those trips are likely to go into the lease area with those changed catch rates. The difference between the trips and the welfare estimates associated between those baseline conditions and those with project conditions effectively represent our measure of changes in economic welfare or well-being. For the charter boating trips, again, because those behaviors are very similar to the private boat fishing trips, we basically scale the results from the private trips to the charter trips. But there is one element that's different for charter boat trips, and that is it has a revenue component. So what we do is, because we have a participation element in the model that says, well, how many overall trips, increase in overall trips, might we predict? We take those increased overall trips, evaluate the change in revenue associated with those overall trips, and then apply that to an economic impact model to say what would be the economic impact of that increased revenue associated with more charter boat trips. On the party boat side, though, again, the behaviors are different, and I think two main reasons why the behaviors are different. On the left-hand side of the figure is an example party boat trip, and they're generally larger than recreational boats, and they typically take trips that are between 4 and 24 hours long. They have upwards of 100 people who take these trips, and the people who take the trips, rather than paying to charter the entire boat, each individual person is paid a per head or a per person fee, and hence the term will be called a head boat as well. Because there is no study in the economic literature about how those folks behave relative to changes in catch rate, we can't apply that same modeling structure. But what we can do is start to look at what is the nature of these trips. And on the left-hand side, we've collected trip data, on the right-hand side, the figure on the right-hand side, we've collected data on one particular boat, and what we see, party boat, is that for spring, summer, they take trips all year long, number one. For spring, summer, and fall, they primarily move around the coast. We're expecting going to reef sites. But then in the winter, those red lines, they go out to the continental shelf. And the research question becomes, with project conditions, might they go to the lease area and fish in the lease area under those with project conditions? I'm going to skip over the summary just in the interest of time, and because this is a state of the science research and our state of the science workshop, focus on improvements and future research kind of for these efforts. The first is honor transfer improvements. So the existing data that we have isn't made for destination and effort-specific catch. The information that we have is just trips that are occurring, and we have to distribute them with the model through space and time. One of the things that Matt and I have evaluated, I would say more appealed for, is if we can change some or add some questions to the access point angler intercept survey, it would go a long way to improving the predictions that we're making from this model. We've done a lot of survey research over time. We've recognized that adding questions adds both respondent burden and interview burden, but the questions we would love to add and advocate for are for boat size and type, and also whether they visit a wind farm. If there's anybody in the audience who'd be interested in discussing that with us, we would love to talk about it. One other just quick point is that our baseline is static, And we recognize that fisheries are dynamic and change over time, and building in that dynamic characterization is one that we'd be very interested in advancing this research too. I'll stop there and just want to note that we greatly appreciate the opportunity to talk with you about this topic. If there aren't questions that I addressed today, please don't hesitate to contact us. We'll be happy to talk about the research. Thank you.
Okay, thanks, Jason. Looks like we've had some good questions come in, so take a look at those and keep upvoting. Next up, we have a security alert.
That's
Fortunately, not a forced restart. Okay, here we go, Daphne from
Thanks.
Rutgers. Thanks.
Hi, everybody. I'm Daphne Munroe. I'm at the Rutgers Haskin Shellfish Lab. I'm really glad to be here today. I'm going to be talking about a number of projects that we've been doing in my lab group in collaboration with a number of other folks at other institutions. Some of my collaborators are listed there. We're a multidisciplinary team that have been doing some modeling studies to look at fisheries interactions and the socioeconomic consequences of displacement from offshore wind energy areas. But what I'm really glad to be here to talk about is this is effectively, right from the very beginning of this conference, we've been talking about the importance of cooperative research in fisheries, right? And even though this is a modeling study, this is very much cooperative fisheries research. We didn't do it on the boats, but we did it very much cooperatively with the fishermen. And so shout out to my fisheries colleagues who are in the room. I see you guys out there. These projects all started from conception with those fishermen at the table, helping us conceive the projects, scope the projects, and then all the way through we were presenting our results to them, getting feedback, and in many cases, models are always wrong. In many cases, they were able to point out places where our models needed to be improved and tweaked. And so really a big shout out to those guys who did a lot of work to make these projects a success. And so I'm going to be focusing first off on the surf clam fishery, and I'll move into some work that we did with the scallop fishery next. We started this work with the Atlantic surf clam fishery because it's a really important fishery in our region. It overlaps with a number of the offshore wind lease areas in development, and we believe it's one of the most exposed commercial fisheries to impacts from offshore wind due to displacement from these lease areas. We also anticipate there may be some survey vulnerabilities. We heard from Catherine that there's real issues with that, and so we used our models to assess some of those things. And the modeling approach we used was one that is not too far different than Jason's approach. We created an agent-based model. So basically, we created a computer simulation environment that recapitulates the fishing stock. So we have a whole bunch of biological calculations that underpin the model and establish the stock in space and time. We have a fishing module in there that is highly specific to the fishery itself. So it has vessels, it has captains. The captains have a memory bank. They make decisions based on weather and conditions and fishing opportunity to decide where they're going to go and fish. The fleet is fully parameterized, so we know how fast the boats go, the fuel burn when they're fishing, those kinds of things are all in the model. And then we have an economics module, and that's really where we make those ultimate calculations of what the impact is if they have to change their behaviors due to offshore wind lease areas. And in that, we have everything from the fleet costs all the way up to the processor and transportation costs when they bring stock to the docks, when they bring catch to the docks. And so I'm going to be covering a lot of ground here, so I'm kind of going to jump straight into some of the results. Our initial simulations, and this was work funded through BOEM, Brian Hooker's in the room. This was a really exciting project to develop the model, and then we parameterized the model and made sure that it was walking and talking like the fishery does today. And then we imposed some limitations on the fleet, and we said, you guys cannot fish in wind areas, right? This is displacement. And then we also said you can't fish or transit through those wind energy areas. This was kind of an extreme case of impact. And then we compared that to the baseline where they can fish as normal and asked the question, what are the revenue and cost consequences to those lost fishing opportunities? And basically, as you would expect, we see a decline in trips. They tend to take fewer trips if there's increased restrictions. They have to travel further to the fishing grounds if they have to go to non-optimal fishing grounds. And those all in concert amount to about a 3 to 15%, depending on the restrictions we impose, loss in revenue fleet-wide. I will say that we did look at port-specific consequences, and Atlantic City is disproportionately impacted. In the worst-case scenario there, that fleet that's just based out of Atlantic City can lose up to 25% in revenues. And that a lot of this cost comes by way of increased fuel costs, right? Everybody knows in the commercial sector, fuel is a big, important part of the economics of the fishery. We do have a number of papers published out of this work, and there'll be a QR code later that you can pick up to get these papers, and I'm happy to talk to anybody more about that or send copies by email. One of the other things we did with this model, because we did a lot of work to try to make sure this model was working and walking and talking in the right way, is we asked a question that we heard from our first speaker, Dr. Sun, was talking about what happens to the stock assessment if, what Catherine talked about, if the federal survey can't go in there and observe what the stock status is in these lease areas. And in the model, we also had a management submodel that goes out and does an annual stock survey that looks like the clam survey, and then makes an assessment of the stock each year. And so if in our model, if we take away the ability of the federal survey to observe the stock in those lease areas and we just zero those out, we know there's still clams there, but we just zero them out because they can't make observations there. Obviously, that changes some of the fisheries metrics that can be calculated out of an assessment, and these are some of those results here. If those portions of the stock are not observed, the fishery can still be operating at the same rate, so the fishery is still catching the same amount, but the assessment can't see a portion of the stock because they're hidden in these lease areas. You end up dropping some of your metrics below what would be the target in some cases for this fishery. So the fishery is not operating differently. The stock hasn't changed. It's simply that the assessment can't see portions of the stock. And so I think these are important things to keep in mind. And so we were asking a similar question to Dr. Sun, but in a very different way. So I'm curious to see how your results are going to come out because you're taking a very different approach to the same question. And then one of the other things that we did with this model, once we had it up and running, in collaboration with Atlantic Shores, we put this model into forward cast mode. We were funded by Atlantic Shores to make an oceanographic forecast for our region. This forecast was done for us by one of my colleagues at Rutgers, Enrique Kirchesser. So he made a future forecast of the entire ocean. We extracted the bottom water temperatures because that's where the clams live, and that's our most important, the most informed habitat characteristic. And then we ran our model on that future forecast to ask, how does the stock distribution change in the future? And then how does the fishery, how does the catch change as a consequence? This is a quick look at some of the habitat forecasts that came out of that model. The yellow and orange areas are the areas that would be surf clammy. So you can see that over time, the habitat tends to expand. And these are important questions because of the longevity of these projects, these offshore wind projects. And then as a consequence of the increased habitat, there's more clams available to the fishery, and so we project regionally about an increase of 60% in biomass. And that translates to an increase between 8 and 13% in catch to the fishery. And what you see over time is that the catch, if they lose access to the offshore wind lease areas today, catch goes down. But over time, that increase in biomass because of increased habitat catches up to what the catch would be today. And then finally, I'll talk really quickly about some scallop works we did. This was funded through the NOAA Sea Scallop Research Set-Aside Program. And we basically took our modeling framework and turned it into a scallop stock and fishery Not so easy. The fleets are they're both shellfish, but the fleets are very, very different. And basically what we saw in that same strategy with a scallop model is that there are, again, losses in catch in particular, and there's differences among ports. In this case, we were seeing very, very small proportional losses in catch on order of about 1%, 1 to 2%. And this is because the scallop fleet travels further and there's less overlap of where the stock is and offshore wind lease areas, so that makes sense. But I will point out that because of the value of that fishery, these very small proportional losses to the fleet may actually translate to very high dollar value losses, just because they're such a higher revenue fishery. And so I'm going to close there. There's a couple of the QR codes where you can find a number of the papers that came out of this work. And again, big thanks to our fishing partners who helped us with all of this work and all of the funding agencies that made it happen. Thank you.
Okay, one more talk in this session. Here we are. All right, so after this talk, if all the speakers could come up to the table for the panel discussion. And with that, please take it away, Kris.
Thank you. All right, I'm the one non-scientist in this whole building, I feel like. Slightly intimidating, but it's been so great to just hear all the wonderful science going on around offshore wind. I'm just kind of an offshore wind policy person, being a fly on the wall for this. My name is Kris Ohleth. I'm the director of the Special Initiative on Offshore Wind. And since Catherine opened the door to it, I will tell my albatross story, because many of us have this story in the room about being on the stock assessment surveys, which I did in my undergraduate years. Well, this was before there were email on the vessels. There was like every other day, there was like a group email account, and you could like find out if someone in your family died or not. That was the extent of the email. So the crew told me on Saturday night at midnight, we're going to go past a green buoy. Write out all your letters. Get them ready. We're going to go past this buoy. It's a mail buoy. You can drop all your letters in the buoy, and then your letters will be taken home to your family and friends. So you can guess what I did, and you can guess what happened. But, you know, we all had our hazings out on the albatross. So anyhow, that is my story of stock assessments. And, you know, such great work you're doing, Catherine, and others to, I think, do the kind of things that really are so heartening, which is create solutions-oriented approaches to the challenges we're facing between, you know, just everything on the planet, but also specifically regarding offshore wind and our interaction with the most important users in that environment existing, which are the fisheries users and stakeholders. So, you know, this work is very heartening, and I'm here to talk a little bit about a project that I've been working on that I'm particularly fond of over the past 2 years, something that is also really kind of a solutions-oriented thing. We essentially at the Special Initiative on Offshore Wind have been convening 11 Atlantic coast states as a peer group, and, you know, kind of working along with our friends and partners at the Consensus Building Institute to help develop a regional fisheries mitigation program. So, you know, the idea is that the 11 states listed here on the slide, from Maine to North Carolina, wanted to create a regional fund so that each time a fisherman needed to be compensated, because, you know, while we're all talking about, you know, all the talks leading up to this are talking about these impacts, right? What are we going to do about the impacts? And as much as we try to avoid and minimize, there will still be impacts that need to be mitigated, and sometimes with financial compensation. All right, so that's what this plan is about. So these 11 East Coast states said, how can we create a regional fund so that, you know, right now there's one for South Fork Wind and Vineyard Wind 1 and Sunrise, and fishermen can independently and individually apply for financial compensation. And they're already kind of confused and overwhelmed by the administrative effort that's required. They're needing to understand different eligibility requirements, different timescales, different potential, impact factors. And so there's a big burden on the fishermen. And the biggest goal, I think, of this program is to really create the accessibility and bring down that administrative and legal threshold for the fishing community to able to be responsive and be compensated. The state's objective overall is to establish a credible regional administrator for managing and distributing fisheries compensatory mitigation funds for offshore wind on the U.S. eastern seaboard. Want to just point out an important fact, which is that the goal of this regional fund would have compensation delivered to any fisherman on the East Coast, and I'll qualify that by saying commercial and recreational for hire fishermen on the East Coast. So not just those 11 states who were listed, even though kind of the bulk of offshore wind is happening from Maine to North Carolina. If there were other fishermen on the East Coast, the idea is to have open eligibility for anyone in the area who is impacted from offshore wind. Another important thing is that the states have felt strongly that, of course, avoiding and minimizing must be the first tools used in that, kind of classic NEPA hierarchy. And, seeing great work done by BOEM on, that first avoiding step in the siting process and how that all plays out. Minimizing, and that can look like adjusting layouts and things that the offshore wind developers are doing, and then we get down to this level of potential mitigation. The state's objectives were to create consistency, and are still to create consistency across developers and projects so that there's some consistency for the fishermen in this, to create fairness for fisheries across ports of origin or ports of landing, again, the entire U.S. eastern seaboard, to create a one-stop shop for fishermen to apply for compensation, to create a scale large enough to create expertise and efficiencies, and to avoid duplication and confusion in the process. While how money gets into the fund is very important, that is actually outside of the scope of what the states are, kind of have been focusing on in creating a regional fund. The money in would be from offshore wind developers. Typically, that money comes in through the NEPA process. At the conclusion of that review, there is a dollar amount, indicated to be paid to the fishing community, and what's happened in the past is that individual funds were set up. So the idea is that once the developers understand what that financial obligation is, that would then be put into this regional fund for application and by the fishing community. The regional fund administrator will be actually managing everything you see in this blue dotted box. So managing the money once it gets into the fund, and then also being able to distribute those funds after we're looking at the eligibility requirements and a lot of other important factors that I should say have not all or really any been developed yet, because I'll talk a little bit about the timeline at the end, but this regional fund administrator has not yet been onboarded. So looking forward to continuing the engagement with all the stakeholders on the important qualifications and variables and factors that will go into designing and developing the launch of a program. So to get a sense of some other tasks that the regional fund administrator would have and kind of have been scoped out through the process so far is to design a regional fund, to share, to communicate and coordinate and collaborate with the stakeholders in the community, and there are some governance structures set up around that we'll talk a little bit about in a moment, to review claims that come in, to verify those claims, and then to pay out those claims. And there's still a lot of details that need to be sorted over the next 18 to 24 months. We're really at an important milestone now of bringing on a regional fisheries administrator as that third party to then kind of launch this process. So to design and develop the fund, NYSERDA has, on behalf of the 11 states, worked as a procurement agent to bring on a regional fund administrator through a competitive bidding process. So NYSERDA had offered to do that on behalf of the 11 states, which was incredibly generous of them to do. The states, offshore wind developers, and fishermen were involved in an RFI that informed that RFP and how that was written. And then NYSERDA hosted a scoring committee that was also comprised of fishing community, developers, and states to advise NYSERDA on the selection of that final bidder. The design and development phase, so what kind of went out in the RFP was a $2+ million commitment, funds raised by states, foundations, and the offshore wind developers to say, here's a pot of money to use to design and develop the program until it's open for the developer deposits. So that's kind of like, the current stage of this design and development process. So you can see there was originally this kind of RFI and scoping period. Procurement period is now done, and the design and development program is about to be kicked off, with the claims implementation kicking off likely 18 to 24 months from once the regional fund administrator is onboarded. The goal is really bottom-up design and development engagement, so kind of getting the broad engagement from the fishing community and other stakeholders who are participating, then funneling down to focus groups, ad hoc workshops, and other ways to collect information, and funneling all into what is being called a design oversight committee. And this will be the committee that is aligned for the commercial fishing industry to be able to provide, when I mentioned the governance structure, to be able to provide feedback into the regional fund administrator, recognizing that the RFA, the administrator, has the final say in making these determinations, but importantly having inputs from the Design Oversight Committee, which really is specific to the commercial fishing side. But then on the recreational for hire side, there will also be a parallel working group and committee that is established. And I guess I should mention the Design Oversight Committee applications close July 19th. So see me if you're interested in learning more about being part of the Design Oversight Committee on the commercial fishing side. The recreational fishing side is about to open in the next month or so. So keep in touch on that. But each one of these committees would be comprised of fishing community members, state reps, and offshore wind developers. And each one of those caucuses is self-selecting the members who would be on those committees. Importantly, the regional fund administrator needs advising on, what would be considered eligible, who would be eligible for this program, what type of evidence of impacts or burden of proof should the fishing community need to provide, what type of impacts are compensable, what type of multipliers should be applied to shoreside communities and, kind of the up and down the chain, what type of data sources and verification would be needed, for example. Overall, the regional fund administrator is tasked with a very robust stakeholder engagement plan that is currently being developed and will be reviewed by the fishing communities and committees. So I'm just going to run past this slide because I just told I had 1 minute left. And I wanted to tell you kind of about where we've been and where we're heading. So this whole program started back in June of 2021. And you can see now we're at this kind of exciting point in the summer of 2024 where soon there will be an announcement about the onboarding and hiring of a regional fund administrator in the next few months. And then this design and development phase can begin. So this is my contact information. I would love to speak with anyone. I do love a good offshore wind text. That's my cell. So write that down. And I think we're all going to come up now and do Q&A. So thank you very much.
Check. So that should wake up. And try to keep the mics separated. So
guaranteed, I'm going to mess that up.
okay. Thanks for all the great questions in the chat. Please keep taking a look at that and upvoting the ones that you'd like to see asked. And I'm going to do my best here to get through a bunch of them. We have about 25 minutes before lunch. So, Catherine, this will come as a complete shock to you, but there are a lot of questions for you and the Northeast Fisheries Science Center. So I think we'll start with you. So, Catherine, can the fisheries monitoring plans conducted by offshore wind developers help to supplement any of the lost data from the Science Center surveys?
Yes. So this is something that we have talked about quite a bit internally. And it depends on a lot of things. We are being very careful and very precise about the data that we think is really important and the data that we need for it to be able to be integrated into an index for the bottom trawl survey. So there's very precise criteria and data collection methods that we think are really important to uphold. So if those are followed very precisely, it's possible. The other thing that we're really worried about is the length of time data is collected for a lot of developer monitoring. The length of time that data is being collected is much shorter than a lot of the survey data needs that we have. So the shorter data collection time range is concerning for us. But there is a possibility that if those methods are held very consistent, if we have access to that data and it's shared openly, it is possible. But there's kind of a lot of conversation that needs to happen. We need to make sure that the methods are consistent. There's kind of a lot of pieces that need to fall into place for that to happen, but it is possible. And I'm sure that's not a very satisfying answer.
Yeah, great, thanks. And by the way, if there's anyone else on the panel who wants to jump in on any of these, even if they were specifically for a different panel member, then please do. So if anyone has anything to add there. Okay, so I think we'll go to Daphne. Daphne, can you speak to how the fishing industry is reacting to your findings? And do you have any suggestions for mitigation measures do they have any suggestions for mitigation measures that they'd like to see explored?
Yes, I think the industry is really engaged in how mitigation can move forward in the surf climb sector, certainly. And we're going to be having some conversations about that later today. But I think in terms of the results, I think, and again, in the way that we structured the projects, we engaged that sector early. They were part of concept design right out of the gates. And so in terms of how they're reacting, I think, all of it tracks for what they would expect to come out of these models because they were part of the development, they were part of the validation, they were part of, they've been being updated very regularly on our results. So, yeah.
Okay, thank you. Question from Ming. Ming, do you think your approach will perform differently for mobile versus non-mobile species? And do you think your approach is sensitive to the longevity of different species?
Yeah, thanks for the question. So I think, first of all, the modeling framework we propose is kind of universal, so you can basically apply that to any species as long as you have the data. And in terms of the mobile, non-mobile species, so in our project, we considered both mobile and non-mobile species. So we anticipate there could be some differences between these results. And sometimes it could be species-specific, and sometimes it could be related to mobility. But I think one of the factors here is mobility really is a factor when you try to model spatial abundance distribution when it comes to spatial autocorrelation kind of assumption. So statistically that could be an effect. And for longevity, I think for some species stock assessment, they do have a requirement on the abundance data at each specific level. So I think that could be an effect also in stock assessment model setting. When you have age structured model, that could have something to do with recruitment dynamics, with how the catchability changes between age groups. So we believe both mobility and longevity could have an effect on our project results. And we're looking forward to see some of the results related to this aspect. Thanks for the question.
All right, thanks. Jason, you're up. Can you share the origin of the prime fishing areas map layer and characterize your confidence level, whether there are any data about the use levels for each, or is there an assumption that all the prime fishing areas enjoy equal use by fishermen?
The source of the first thing I'll say about the prime fishing grounds is that information has come to us relatively early or soon. We haven't had it for very long. So within the modeling structure specifically, we have not evaluated whether or not there is catch rate specific information within those prime fishing grounds, number one. Number two, does that information, if it's available, vary from the open access site data that I described and the reef site data? So unfortunately for my presentation, the illustration of the prime fishing grounds is in there because we've been given those sites basically as shape files, and we want to recognize that data is available, but we actually haven't started working on that data yet, but it is something that we expect to use. I think relative to the second part of the question, would we expect that the trips would be equally distributed across those? My expectation is that they would not, but that's just an expectation, and we'll see as we start to evaluate that data.
Okay, thanks. A question for Kris. How will losses in revenue from offshore wind be separated from losses due to climate change / natural fluctuations or fisheries that are already in decline for some other reason?
Yeah, it's certainly a big challenge. It's something that we'll have to work through in the design and development phase of the program. But we're certainly seeing a lot of changes in the environment currently, and so being able to disambiguate them from the offshore wind impacts will be a challenge. When we've talked to some of the claims administrators who have worked in everything from 1-800 talcum powder to PG&E fires in the West, they've covered this huge swath of kind of horrible things people need to apply for claims about. They tell us that sometimes there are just changes and challenges in the system that we need to have a margin of error to account for, and there's amount of waste and fraud in every one of these types of claims programs that you certainly try to minimize, but there's going to be some you kind of try to reduce the amount of uncertainty in the system, and it's kind of impossible to bring it to zero.
Yeah, I think that's a challenge we're all facing, is disentangling effects of non-stationarity with the effect of interest. I'm going to kind of merge two questions for Catherine here, and then, of course, if there's anyone else on the panel that wants to chime in. So, Catherine, the one question was about what really is the spatial limitation with respect to the survey vessel entering and sampling in the lease areas, and then the related question is, couldn't we just come up with a cooperative effort to use commercial vessels that are smaller, maybe more nimble, that are able to sample within those areas?
I was expecting this question. It's a hot topic right now. So our NOAA white vessels are run by OMAO, which is another part of NOAA, and they've released a policy saying that those vessels are not going to be permitted to have towing operations inside wind areas. So we are limited by that policy for the Bigelow to be able to tow inside those wind areas. So this is just going to be we know that the Bigelow and all of the sister ships will not be allowed to tow inside wind areas. In our mitigation plan thus far, and we've approached this as we wanted to come up with kind of the scientific solution for what data do we need, knowing that our current operations cannot continue inside those wind areas. So we approach this as we want to know what data we need, and we don't necessarily make any conclusion about what vessel that data needs to be collected on. So we were being very vessel agnostic. So there are a lot of conversations going on right now at different councils and at NTAP meetings about how we are going to accomplish that and about the different mechanisms. I am not necessarily the right person to comment on that, but there's a lot of conversation, and at this point, I think there's a lot of opportunities to work together with a lot of different partners, and we're trying to consider that and consider how do we make something work, and how do we provide the best data, knowing this future is very uncertain, and we need to be able to be continuing to provide the best data possible.
Yeah, go ahead.
Just to add to that, on the commercial vessel side of things, I think there's a real opportunity space right now with the developers are, a lot of developers are thinking about their fisheries monitoring plans right now, and I know a number of the developers I've heard from are interested in engaging commercial vessels in those plans, and so that becomes maybe an opportunity for a test bed on some of those, those ways to fill some of those data gaps. And so, hats off to the developers for wanting to engage the commercial fleets on that.
Yeah, can I chime in? Yes. So here I think one of the issues I was thinking of is it's not only about how to collect and what to collect, in terms of data, but what do we want to work with this data? So according to our modeling results, one thing is we can definitely do some monitoring inside and outside offshore wind separately. And it comes down to what kind of questions you want to address. For example, if you just want to look at the inside offshore wind area stock abundance, probably a more specified, well-designed survey could work way better than a generalized, designed, large-scale survey in the entire Mid-Atlantic area. That's one thing. I think the second thing is, what do I have? Yeah, I'll come back to this. Yeah, sorry about that.
Okay, Jason, this one I think is for you, but if anyone else wants to chime in, it's not identified as for you. It sounds like there's an assumption that the lease area will create a positive reef effect. Is there any way to run the model, or have you done so, to evaluate whether the effect might actually be negative in nature and that recreational anglers would avoid the area?
Yeah, because the model is simulation-based, we can effectively go in and change the catch rates within the lease area to be both kind of multi-directional, so an increase and a decline. Also then a change from open sandy bottom and open ocean site to a reef site, as we've done. So that structure exists within the modeling framework. Based on the conversations that we've had to date, our expectation is that it would be, one, that direction to a reef shift, and two, then catch rates that would be expectation-wise similar to what we expect to see from the reef sites. But and I think this is one of the things that is we're very interested in relative to kind of our participation in a workshop like this and this type of work, is that it's very much interdisciplinary, it's very much collaborative. We're very accustomed to kind of working with fisheries biologists and engineers in terms of design of different systems and saying, no, we think that there's kind of a better assumption or better data that you can use to build into that structure of the analysis. So that is definitely a possibility. It can be run as just scenario analyses, but it can also be run as improved specification as the science improves, as more lease areas are developed and more specific data is collected around those individual structures.
Okay, great. I kind of want to stay with this topic of the reef effect, because there's a question here for Daphne about considering whether the offshore wind areas could act as source populations that might actually increase productivity in open areas. And Catherine kind of alluded to this too, about sampling around the perimeter of offshore wind areas.
Yeah, thanks. And I think there are a number of questions in the string that are kind of related to increases in clam biomass. Did we consider that if you're not fishing in these areas, you may increase the number of clams and therefore the number of larvae that are coming out of those areas and de facto marine protected areas, et cetera, right? So one of the things about this fishery, the clams don't recruit into the commercial fishable sizes until they're about 5 to 7 years old. They start reproducing at about 1 to 2 years old. And so there's a number of years that they're reproducing before they're even recruited into the fishery. And so we don't see this as a broodstock limited fishery, and we see that in the way that the assessment is structured. So we don't anticipate, even if there was an increase in broodstock within these lease areas, it's not a broodstock limited fishery. And so we don't think that there'd be an increase in larval export because it's not a limitation for this stock. But in our simulations, we were able to look at what happens if you cannot fish in there. What happens is some of your larger adults stick around longer, and that translates to an increase in biomass. They're very large-bodied, so those biggest animals really dominate the biomass. And so you can see a little bit of a biomass bump when the fishery's not operating in those areas. But again, we don't think that necessarily translates to a change in the recruitment potential. But the other thing that we did not put in our model is we did not put loss of habitat in those wind lease areas. And we know by definition that's going to happen because the developers are going to put hard structure down. By putting those scour protections down, you are by definition removing clam habitat. We didn't account for that, so there's probably a little bit of a balance there, and we don't know where that would settle out. And so that's a consideration that we did not include. And that leads me to a final point that when I hear people talking about these areas as marine protected areas, if the fishery can't operate there, I think we should be really careful about that conversation, because a marine protected area for clams, I would sit down and put a wish list together of what you'd want to do, and it's not necessarily the same consideration that Brian and his team put into locating these wind lease areas. And so it's not maybe an ideal clam protected area, for example. So I caution that conversation a little bit, but yeah. Did you want to? Okay.
Yeah, go ahead, Jason.
One other element I want to add to this overall discussion about kind of the temporal aspects of these evaluations and these models is that when we stand up and talk about them, initially we're evaluating things from the data that we have right now, a static evaluation, and to some degree making the best projections that we can over time. But the evaluation we have to do is temporal, and effectively what's going to happen over time, because these installations are going to be there from a long time and there's so much data collection, is we're going to be able to update these models. And I think that ties into the compensatory mitigation fund, that it's something that I think we'll be evaluating over time, because we're going to have more information. We're going to run scenarios now, and we're going to get to see how they play out, and we're going to get to update them with new data and new information. And I think that's something that's very interesting relative to this dynamic, and I'm curious your reaction to that.
Yes, absolutely. And one thing that I didn't mention in the overview is that really, the idea is to kind of have like a 5-year assessment. I mean, kind of running assessments, but the first 5 years is an important milestone as the fund is established and starts being used, and getting a sense of, is the fund, for example, a big concern is, will there be enough enough money in the fund to cover all the impacts? And if not, then how are we sourcing additional funds from developers or otherwise to make sure that all the claims are paid? And, so there's going to be a lot of important, I think, references and evaluation on that first, kind of annually, but then at that 5-year mark.
Thanks. And Kris, I want to stay with you. This person remained anonymous, but identified this as a tough question. So, so brace yourself. Do you think it would be more effective or proactive to put more effort into advancing fisheries now to ensure their success in the future through things like gear modifications, infrastructure, and marketing, instead of compensating for their losses down the line?
Oh, come on. 22 years, that's not a tough question. Thanks for it, though. Definitely recognizing that, and the states have done this in parallel, where there are funds that are kind of more for sustainability and resilience programs. So while, developers have dedicated funds for claims for the current programs like Vineyard and South Fork, there have been parallel funds that are kind of designed more for that type of program, where there could be upgrades to gear or radar or, other type of programs that are helping companies and businesses adapt to this new environment that we will be seeing. And so I think one wouldn't replace the other, but they can work complementarily in a parallel way, and that's what would be envisioned in this program as well.
What a nimble handling of a tough question. Catherine, this is right now our currently most upvoted question. Has the Northeast Fisheries Science Center considered looking into non-extractive monitoring methods?
So yes and no. We have some methods that we are currently using that are non-extractive. So for example, we use HabCam. We have a long-range AUV that we recently was out on the Bigelow and came back. For the bottom trawl survey, one of the most important pieces of data that we're collecting is coming from biological sampling. And right now, that data requires extractive sampling. There's no way around it. There's no way that we can get a lot of the data that is used in stock assessments that's really critical without doing extractive sampling. And as much as it would be great if there was another way that we could do this without killing fish, currently those methods don't exist, and we need this data to be able to do stock assessments and to be able to do a lot of the science that a lot of people in this room are doing. So in the future, like having this conversation and being able to completely switch to a non-extractive method would be great. This is something that we are thinking about in the context of floating wind in places where, we are aware that it's going to be really hard to be able to use mobile gear to be able to do trawls in places where there are potentially anchor lines in a lot of places. So we're starting to think about, what type of modalities can we use in places where being able to fish in ways that we always have in the past might be impossible, and what are ways that we're going to be able to get data or get the best data that we can. And we're having these conversations now about, are optical methods kind of the way forward? Are using eDNA, is that going to get us some data in places where we otherwise wouldn't get any data? But right now, extractive methods, there's really no alternative for a lot of the things that we do really need to be able to do kind of foundational science.
Thanks, Catherine. But just to follow up, couldn't those things like stock assessments and how right now they're age structured, couldn't, for example, that be changed to a size structured stock assessment, and then with the utilization of non-extractive gears like baited underwater video cameras in stereo, could you get size instead of age and just rethink the need for putting your hands on dead animals to do this?
I think for some species, for some methods, there are ways that you could start to think about that, but even when you were starting to think about in any sort of baited modality, we have to think about bait plumes. How are we attracting fish? There's a lot that's going into any of these modalities that we really need to start thinking about very carefully, and we also need to have that conversation with all of our assessment scientists. Is that appropriate for a given species? Is moving from an age-based model to a stage-based model appropriate for every species that we're talking about? So is removing a complete modality of surveying where we're providing that data for 54 different stocks, is that appropriate to kind of completely tell these 54 different stock assessment scientists that you no longer have that option to choose what type of model you're using?
Got it. Thanks for letting me push back a little bit on that. Okay, we have about 1 minute left, and in the interest of beating the people from Ballroom B to lunch, I think I'll just open it up for any final comments from our 5 excellent panelists here.
Yeah, my forgotten answer just got back to me. So I think when we try to work with data collected from different sources like developers and the federal surveys, so one thing is sometimes certain stock assessment you can just throw in different time series because it's not uncommon for stock assessment to use multiple time series abundance. But one thing is when you try to work with other objectives, for example, spatial distribution modeling, you somehow need to kind of standardize all the different data you have. You need to like reconcile their different catchabilities, different even numerically magnitude. Otherwise, your results are going to be dominated by very large values. So that's one thing to consider. Yeah.
I just say as a non-scientist in a time where, science is, being threatened and misinformation is rampant, being here these past few days and seeing kind of like what you all are doing on the science side is so heartening to me when I meet stakeholders who say, there's no science happening. I was at the poster session last night almost crying. It was so beautiful. So, let's keep this beautiful science conversation going. This is just huge props to NYSERDA and all you for the work. It's just great.
Well, that's a tough act to follow. So thank you all very much. Let's give our panelists one more round of applause.